Welcome to clickmyproject.com. Let me discuss the project about Rayleigh executor model for plaque characterization in intravascular ultrasound. In this paper, we propose to model the tissue echo morphology by means of an executor of Rayleigh distribution, known as the Rayleigh executor model. The problem formulation is still simple, but its ability to describe complex textural patterns is very powerful. We have to present the method for the automatic estimation of the RMM executor parameters by means of the expectation maximization algorithm, which aims at characterization tissue echo morphology in ultrasound. Rayleigh distribution is a fully automatic method for contour segmentation. The results of image segmentation is a set of segments that collectively cover the entire image or a set of contours extracted from the image. Each of the pixels in a region are similar with respect to some characterizations or computed property, such as color, intensity, or texture. Adjacent regions are significantly different with respect to the same characterization. It's the block diagram of our project. First, we will load the IVUS image. Is considered a suitable techniques for in vivo characterization of the coronary plaque composition. The next one is pre-processing. If the weights in filter kernel represent Gaussian coefficient, a Gaussian filter is obtained. Gaussian filter is effective when image noise is zero mean. Gaussian filtering is rotationally invariant. The next one is feature extraction using GLCM, gray level co-occurrence matrix, or associated texture feature calculations or image analysis techniques. Given an image composite of pixels each with an intensity, the GLCM is a tabulation for how often different combination of gray levels co-occur in an image or image section. Texture feature calculation use the contents of the GLCM to give you a measure of the variation in intensity at the pixel of interest. The virtual variable is created in the following way on the GLCM texture page of the variable properties. The next one is classification. A nearest neighbor classifier. It's the pattern recognition is a method for classifying objects based on closest training examples in the feature space. KNN is a type of instant based learning or lossy learning where the function is only approximated locally and all computation is deferred until classification. The K nearest neighbor algorithm is amongst the simplest of all machine learning algorithm. The next one is segmentation. A segmentation is the process of partitioning a digital image into multiple segments. The goal of segmentation is to simplify and or change the representation of an image into something that is more meaningful and easier to analyze. Image segmentation is typically used to locate objects and boundaries in images. More precisely, image segmentation is the process of assigning a label to every pixel in an image, such that pixels with the same label share certain visual characterization. The next one is analysis. EM segmentation algorithm is a method for finding maximum likelihood or maximum posterior estimates of parameters in statistical models where the model depends on unobserved landed variables. The EM iteration alternates between performing an expectation step, which creates a function for the expectation of the long likelihood evaluated using the current estimate for the parameters, and a maximization step which computes parameters maximization the expected long likelihood found on the step. These parameters estimates are parameters of the statistical model in cases where the equations solved directly. Finding maximum likelihood solution requires taking the derivatives of the likelihood function with respect to all the values. The EM algorithm processed from the observation that the following is the way to solve these two sets of equations numerically. One can simply pick arbitrary values for one of the two sets of unknowns, use them to estimate the second set, then use these new values to find a better estimate of the first set, and then keep alternating between the two until the resulting values. Now let's see about the execution part. I am having a main.m file and select the file, right click, run the file, Rayleigh executor model for intravascular ultrasound, and select load image button. Here we have to select the input image. The next pre-processing. Gaussian filter will be fine for input image. Gaussian filtering is effective when image noise is zero mean. Gaussian filtering is rotationally invariant. The next feature extraction using GLCM. Gray level go occurrence matrix quantifies the image data. Each sample on the echogram is treated as a single image pixel, and the value of the sample is the intensity of that pixel. These intensities are then further quantized into a specified number of discrete gray levels as specified under quantization. Normalized the GLCM, divide each element by the sum of all elements. Each elements of the GLCM may now be considered probabilities of finding the relationships. Calculate the selected feature. This calculation uses only the values in the GLCM. Several statistics information are derived using the different formulas. These statistics provide information about the texture of an image, such as angular, second moment, entropy, contrast, inverse difference, moment correlation, sum of squares, sum of average, variance, entropy will be calculated for texture image. The next classification, it's the quadratic plque. The same method can be used for regression by simply assigning the property value for the object to be the average of the values of its k nearest neighbors. It can be useful to weight the contributions of the neighbors so that the nearest neighbors contribute more to the average than the more distant ones. In binary classification problems, it is helpful to choose k to be an odd number as this avoids votes. One popular way of choosing the optimal settings in this k nearest neighbor method. The next, segmentation. Image segmentation. The result of image segmentation is a set of segments that collectively cover the entire image or a set of contours extracted from the image. Each of the pixels in a region are similar with respect to some characterizations or computed properties such as color, intensity, or texture. Adjacent regions are significantly different with respect to the same character. The first region growing method was the seeded region growing method. This method takes a set of seeds as input along with the image. The sets mark each of the image segmented. The regions are relatively grown by comparing all unallocated neighboring pixels to the regions. The next, analysis. It's the histogram for probability density and intensity values. And the next, it's the EM method. EM, expected maximization segmentation algorithm, is a method for finding maximum likelihood or maximum estimates of parameters in statistical models where the model depends on unobserved landed variables. Some likelihoods also have singularities in them. The EM executor model involves setting one of the components to have zero variance and the mean parameter for the same component to be equal to one of the data points. Practical statistical data clustering algorithms require multiple data scans to converge. For large database, these scans become probability expensive. We present a scalable clustering framework requiring at most one scan of the database and apply it to the expectation maximization algorithm. It's the EM algorithm processed from the observation that the following is a way to solve these two sets of equations numerically. One can simply pick arbitrary values for one of the two sets of unknowns, use them to estimate the second set, then use these new values to find a better estimate of the first set, and then keep alternating between the two until the resulting values both converge to fixed points. Thank you.